Okay, I'm going to try to wing together this example. Well, actually, it's your homework problem. 4.c. F goes from a into b, and it's defined by this, the natural log of x squared plus 3x plus 2. We want f to be bijective. This is not a bijective function right now, but we're going to restrict a and b to be in such a way that will force it to be bijective. So just as an example, if you have f of x equals x squared, that's not bijective. But if we took only this part of it, that's bijective if we would take a, the domain, to be 0 to infinity, and b, 0 to infinity. Now we've got a bijective function. And remember that I told you one nice, easy, straightforward way to find one-to-one injective functions is increasing functions. Strictly increasing functions are one-to-one. Strictly decreasing functions, you can see, because if that's going down, that's one-to-one, it passes the horizontal line test. If it's not strictly, if it gets a little hump in it, now let me make it a little bit bigger, it's no longer one-to-one. Okay, well, let's review a little bit. What's that graph? That is the graph of g of z equals ln z. That's the graph of the natural log. This is certainly a one-to-one function. If you say it's going from reals into reals, then it wouldn't be, well, the image of this is, the range is negative infinity to positive infinity. It goes all the way down that direction, all the way up that direction. So the domain of G is only positive numbers. The range of G is everything. Okay, so that's just to make sure we understand how the natural log function works. Okay, so what do we have here? Let me erase this. For one thing, the natural log function, you can only take the natural log of positive numbers. So the domain of this function, the biggest it can possibly be, is all of the x's where this is bigger than 0. So x squared plus 3x plus 2. So let's find out where that function is defined. Where is this expression always positive? Well, let's see, x squared plus 3x plus 2 equals 0 means, well, this is stuff that we do in pre-calculus, so it's kind of fresh in my mind. Maybe it's been a while since you've taken it. Factor this to get x plus a 2 and, I'm sorry. Yeah, that's right, x plus 2 and x plus 1. Set those to 0, we get x equals -1, -2. That's where that's equal to 0. So basically, we know what this function is. It's a parabola, right? And we just found the x-intercepts. So this function that you're taking the natural log of looks something like that. So that function, f of x, is not even defined for numbers between -1 and -2. Can't plug it in. So a could not possibly contain the numbers from -1 to -2. But we need to do a little bit more. We need to know where that function, well, actually we already know this, don't we? This function, the inside function, I need to know something about ln of x squared plus 3x plus 2. Where is it increasing and where is it decreasing? We have to take the derivative. So, derivative is equal to 1 over times the derivative of this, which is 2x plus 3. All right, so that's the derivative. I want to find out where that's positive and where it's negative. Where it's, if from some point on to infinity, it's positive, that means it's an increasing function and it's 1 to 1. If from some point to infinity, it's a decreasing function, that means it's a 1 to 1 function. Or from negative infinity up to some point, that's the kind of thing we're going to use for A. It's either going to be a number to infinity or negative infinity up to a number. All right, so this is equal to 0 when x is equal to negative 3/2. We need to do a little bit more than that. Let's find out where this is. Yeah, let's go ahead and say, what I say in my pre-cal class is find the boundary points of this function. The boundary points are where it's equal to 0 or it's not defined. That means you set the numerator equal to 0. 2x plus 3 equals 0 means x equals negative 3 over 2. So if you plug in x equal negative 3 over 2, you're going to get 0 here. And remember what that is. That's the slope of our function. It would be flat at that point. Okay, so where is it undefined? So let me just write negative 3 over 2 is a 0. X squared plus 3x, I already did this, right here, equal to 0. The function f of x undefined at negative 1, negative 2. So all we need to do is look at the real line, plot those points, negative 3, let's see, negative 2, negative 1, negative 3/2. Okay, here this function is equal to this function, the derivative is equal to 0 there. Between negative 1 and 2, okay, good. The function f of x is not even defined between negative 1 and 2, negative 2 and negative 1. It's not even defined, right? Because you can only take the log of positive numbers. So we're down to 2 options. And you could use either one of them. From negative 1 to infinity, I'll say in negative 1 to infinity, f is increasing. That is 1 to 1. So it's certainly, so it would be injective from negative 1 to infinity, or from negative infinity to negative 2. I don't know if it's increasing or decreasing there. So now you need to simply figure out what the image of the function is at that point. And I believe it's simply going to be the range, I believe it's going to look like going from negative infinity up to positive infinity. In either case. That's a good question. It's increasing. So, okay, it's increasing. Then we can say, what is ln of x squared plus 3x plus 2? It's an increasing function from negative 1 to infinity. So therefore, what is the limit as x goes to infinity of that? Clearly goes up to infinity, right? You're taking the ln of x squared. You're taking the ln of x goes up to infinity. So ln of x squared will go up even faster. So the range, so a we know is we can choose a to be negative 1 to infinity or negative infinity to 2. I would pick negative 1 to infinity. And then the range, so we've got the domain being, a, the domain being negative 1 to infinity, and b is something to infinity. We know it goes up to infinity. I bet you if we take numbers that are extremely close to negative 1, like negative 0.9, and plug that into a calculator, we're going to get negative 0.99. We're probably going to get a number very large in the negative sense. Let me see. I don't have a calculator handy, so I'm using I have to use my computer. Calculator. All right, so I'm going to take 0.99 squared. 0.99 squared. Plus 3 times 0.99 plus 2. And then I'm going to take if I can find where I get the natural log, scientific. All right, I got to start over because now I've got the scientific. All right, so I'm going to say 0.99 negative squared. So this would be minus 3 times 0.99 plus 2. So that gives me 0.0101. When I plug in a negative 0.99 into this, it gives me a negative 0.0101, which we know is going to be a very large negative number, if that makes sense, large in magnitude. So now I'm going to take the natural log, and I get I got negative 4.5. Let me try this again with even a smaller number. I mean, with what I mean is 0.9999. Square it. And I'm using negative 0.9999. So minus 3 times 0.9999 plus 2. All right, now I'm at 0.0001. And now I'm going to take the natural log. It's only negative 9. So now I'm going to see if I go clear it. I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 nines. point with 10 nines, square it, minus 3 times point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 plus 2 equals. Now I got about, I don't know, 8 or 9 zeros, 9 or 10 zeros, and I got negative 23. Well, it's not going negative as fast as I thought it would, but it would be fun to just verify if you got time with a calculator, with a real calculator. Plug in 0.9999, like negative, let me see here. Yeah, negative point, and then like 59s, just to see, but I don't want to take the limits, but I could. I believe it's negative infinity to infinity. I think we might have to take a limit. The limit as x goes to negative 1, it's going to have to be negative infinity. The limit as x goes to negative 1 from the right-hand side of this. So work on that. I will too. See if that helps. Maybe I can give you other help. I'm going to figure out the answer, but let me know what you get.